Okay, in this video we're going to evaluate the 6 trig functions and all the quadrants. So let's go ahead and start. Learning goals. Students will be able to evaluate the 6, so let me grab my highlighter here, the 6 trig functions and all the quadrants. So this is why you learn the unit circle. This is a pretty big deal here. Remember that we're going to use the reference angles, and the reference angles live in the first quadrant. We're also going to basically use all students take calculus to figure out where sine, cosine, and tangent are positive or negative. And please do note that in the different quadrants, like the second quadrant, the x value is negative. In the third quadrant, both the x and y values are negative. And in the fourth quadrant, the y value is negative. Okay, so just to warm us up a little bit, sine 5 pi over 6. Okay, first things first, to figure out the reference angle, remember that we're just going to look at the denominator. So denominator is 6, and in the first quadrant, the only angle that deals with something as a 6 in the denominator is pi over 6, which is 30 degrees. So I know here that I'm dealing with my reference angle as pi over 6. Other helpful tools, where the heck is 5 pi over 6? Now, to figure that out, simply let's take a look at the fraction in front of pi. That's a little less than 1. And the reason why is 5 divided by 6 will give you some decimal. So it's got to be between pi over 2 and pi. So it's going to live here in the second quadrant. Okay, so how does this help us? Well, remember, if we did our little trick 1, 2, 3 down and 1, 2, 3 up, we basically get our ordered pair. And we remember that we're looking at the sine value. So here in the second quadrant, we know that the x value is negative and the y value is positive. And so we can quickly, at 5 pi over 6, we can quickly say, hey, the answer is 1/2, and be done. Alright, so I kind of wrote over example 2, so let me go ahead and erase 5 pi over 6 real quick. Okay, so now for example 2, we're going to do the same thing. Now we have 11 pi over 6 in this case. Remember that we're going to look for the reference angle first. So it looks like my denominator is 6, so in the first quadrant it would be pi over 6 again. How convenient is that? Now what I have to figure out is, where the heck is 11 pi over 6? So 11 pi over 6. If we think about 11 pi over 6, and I divide it, it's really close to 12 over 6, which would make 2. So we're really close to 2 pi. So that would mean it would have to live in the fourth quadrant. Okay, so it would be between 3 pi over 2 and 2 pi. So 11 pi over 6. Now in terms of the order pair, it's simply going to be in reference to 30 degrees, which is pi over 6. So that would be radical 3 over 2, just like before, comma 1/2. Now we know in this quadrant that the y value is negative and the x value is positive. So let's go up and see what we want. We want cosine 11 pi over 6. So we definitely want the x value. So the answer to this one would be basically radical 3 over 2. Okay, so I think we're warmed up. We're ready for the show. Let's go ahead and let's start with example 3. Okay, in terms of example 3, it looks like they gave me a table below here and they want me to fill it in, so not a problem. And lots of information up here. Let's go ahead and do the actual first quadrant so we have something to refer to. I'm not going to draw the degrees just because my table's in radians. So 0 radians, pi over 6 radians, pi over 4, pi over 3, and pi over 2. Remember, this is 0, 1, and this is 1, 0. We're in good shape here. If we count down 1, 2, 3, and then up 1, 2, 3, stick them all over 2. I don't know why I like saying that, but I do. Take a square root of the tops. We have our first quadrant. Okay, so it looks like the table is dealing only with values from 0 all the way to pi, so 180. Okay, no worries. To find sine and cosine, it should be fairly easy. For sine, we're looking at the y values, so sine of 0 is 0. Pi over 6 is going to be 1/2. Pi over 4 is rad 2 over 2. Radical 3 over 2 is going to be the next one. And then finally 1. Now, if we want 2 pi over 3, that's the second quadrant. And we'll take a look at that in a second and see how easy it will be to generate that. But let's go ahead and let me grab another color here. Let me grab green and do for cosine. Cosine at 0 radians is going to be 1. We have radical 3 over 2. We have radical 2 over 2, 1/2, and then finally 0. Okay, let me change colors. Let me get back to my second quadrant here. So in the second quadrant, it says up here that the x is negative, which I don't have to worry about for sine. But if we were to sketch this, okay, so if we were to actually, sorry about that, sketch this, 2 pi over 3, we know that has a reference angle of 60 degrees because of the 3 in the denominator. So 2 pi over 3 would be right about here. The next one would be 3 pi over 4, which is reference angle 45 degrees, pi over 4. Next one would be 5 pi over 6, and last one would be pi. Okay, so in terms of order pairs, we would just mimic, in this case, 2 pi over 3, the order pair would be the same as for pi over 3, which is going to be basically 1/2 comma radical 3 over 2, but my x values are going to be negative. So if I'm looking at the y values, this would just be radical 3 over 2. Now, what we could do with our table is we could just kind of look, hey, look, there's the reference angle. Make sure you put the right positive or negative in front. So in this case, it would be rad 2 over 2, and it would be positive because it's the y value. For 5 pi over 6, the reference angle is right there. That's 1/2. And then for pi, we basically have this. This is the order pair -1 comma 0, so it's going to be 0. Okay, so let's go ahead and do the next one for cosine. And for cosine, I know that these values are going to be negative because of the x value in the second quadrant. So I'll just go ahead and put negatives. Okay, 2 pi over 3, we can look at basically pi over 3, so that was 1/2, so it'll be -1/2. 3 pi over 4 references pi over 4, which is rad 2 over 2. 5 pi over 6 references pi over 6, which is going to be radical 3 over 2. And then in this case, it'll be -1. Nice and easy, huh? Not too bad. Okay, to generate the rest, basically tangent is sine over cosine, so this would be 0. This would be 1/2 over radical 3 over 2, and I'll let you simplify later. This will just be 1. I'm just sticking sine over cosine. This will be radical 3 over 2 over 1/2. This will just be 1 over 0, which is undefined. Negative radical 3 over 2 over 1/2. -1. 1/2 over negative radical 3 over 2. And then 0 over -1 just gives you 0. Okay, we're in great shape. To find cosecant theta, just take the reciprocal. Reciprocal of 0 is going to be 1 over 0, so undefined. Reciprocal of 1/2 is 2. Reciprocal of the next is 2 over radical 2. 2 over radical 3, 1. 2 over radical 3. 2 over radical 2. 2, and the reciprocal of 0 is 1 over 0, which is undefined. Okay, we're doing great, almost done. Reciprocal for cosine, we get 1, 2 over radical 3, 2 over radical 2, 2 over 1, 1 over 0, which is undefined, -2, -2 over radical 2, -2 over radical 3. Sorry if I'm going too quick for you. -1. I'm just taking the reciprocal of cosine. Finally, the reciprocal of tangent will give you cotangent. So that would be 1 over 0, which is undefined. Radical 3 over 2 over 1/2. 1/2 over radical 3 over 2. This will just now give you 0. -1/2 over radical 3 over 2. -1. Almost done here, guys. Negative radical 3 over 2 over 1/2. And finally, this would give you -1 over 0, which is undefined. Okay, so much that I had to break it up into 2 parts, but let's see how we're doing with our learning goal. Students will be able to evaluate all 6 trig functions in all the quadrants. You'll be able to do this especially after the next video that does the 3rd and 4th quadrant. I'll see you on the next video. Thanks.